Linux playgrounds and becoming literate, becoming Nix operating system literate, becoming portable operating system literate. Because as of Windows 11 and the easy ability to install Linux side by side with Windows, which is new under Windows 11, possible under Windows 10, but refined under Windows 11. With that comes the consolidation of Nix as the across the board, uncontested, dominant platform for development and developers and just doing things in tech in general. Who would create something under a proprietary operating system where you have to spend money for every instance? Does there need to be a second reason, but by which you are beholden to a vendor and vulnerable to changes? Is that one or two things? Well, beholden to the vendor is kind of the same as having to spend money to get it, but having to abide by their rules and be screwed when the rules change. Be vulnerable to the whims of a proprietary product. There's no, well, free and open source has its issues there too. It's not like it's a panacea. It's not like it's a cure-all on the free and open side. But the difference is a nuanced one. When software is free and open sourced, if it becomes abandoned by its original developer, other people can fork it, maybe even take over the original repository and continue developing it. It's open. Because it's open, it can change hands. Because it can change hands, things that are worthy and worthwhile can often have longer lifespans than their proprietary equivalents, which are going to be continued or discontinued or changed as products for reasons of profit. Quarterly earnings, for example. So, why tie your product to something where the platform itself is volatile in how it's subject to quarterly earnings expectations? So, if an API has to change in order to drive people into the next upgrade cycle, then an API is going to change on you. Your old code slowly starts to become obsolete, deprecated, they say, depreciated? No, it's deprecated. And in time, broken. They usually give you a deadline by which you have to change over to the new ways. And that happens everywhere. That doesn't just happen on proprietary, that happens on open source stuff as well. However, there are veins within the open source world, not all of it, but there are super valuable subsets of the free and open source world that takes their API changes very seriously. In fact, seriously enough to make benevolent dictators for life get fatigued and step down. Now, Guido van Rossum, as the benevolent dictator for life of Python, didn't directly step down because of the contention of going from 2.x to 3.x, but it certainly, set the stage for the subsequent battle over the walrus operator. And the walrus operator was the straw that broke the camel's back, and Guido stepped down. He's still involved, I believe, in whatever it is that replaced it, the Python.org steering committee or something. And Guido basically said, let the free and open, let the community work it out. And if the community doesn't work it out, I'll come in and choose a solution. But the community worked it out, and Python continues to move along very nicely, and is not becoming some super volatile, things change all the time platform. And you can tell that by it getting up to 3.10. And so, isn't that 3.1? Don't you just convert it to decimal? No, you don't. It's a string system. Python is up to 3.10. You cannot turn it into an int or a float. It would give you the wrong version number. It's got to remain a string, which is like another one of these inside jokes. Honestly, there's so many funny things in tech, and the fact that Python is up to 3.10 and it's not being compelled to go to version 4, the Python community would not suffer such a thing after just having recovered from the trauma of the switch to 3.x. The, bitter acceptance that you're on your own if you have really old Python scripts running under 2.x. 2.6 was a super popular version. There's a lot of people running Python 2.6 stuff that really don't see the reason to move even to 3.x to get the Unicode and stuff. Even the little bit of conversions, putting the parentheses in after the print statement, isn't worth it to them for the risk of it breaking. Now, chances are it wouldn't break, and chances are it might even get a performance boost by going to 3.x. There was a time when the resistance to Python 3 was so intense that they decided that the number one feature advantage of 3 should be improved performance, so that no one could level that complaint against Python 3, because everyone wants to say, as an excuse to stay on 2 point whatever, I would move to 3, except my scripts run so much slower. So people who don't want to change are chomping at the bit to give that excuse. So in a clever, highly strategic move, Guido van Rossum and the other Python core developers said, all right, now that we have Unicode in 3, let's give them performance. That's our priority. And that must have kicked in, I don't know, somewhere around Python 3.4, 3.5. And by the time they got to Python 3.6, it was as stable and reliable and complete as 2.6 was before it. So you have two really well pedigreed Python versions out there, 2.6 and 3.6. And as 3.6 creeps along to 3.7 to 3.8, 3.9, and today to 3.10, everybody has the still recent feeling ouchies hurt of the switch to Python 3. So as that number creeps higher, there's this psychological aversion to getting to Python 3.10 because you have to face the fact that they're really string version numbers and not floats. You can't convert a Python version number to a float and expect it to be an accurate representation of the version. I think there were even bugs in pip because of that. They had to update, I believe, the pip program to make sure that version numbers were always interpreted as strings. All right. So, things have changed, ladies and gentlemen. The world is not like what it used to be. For the first time in human history, there is a generic language of tech. Nix 1. Apple came around in 2007, moved OS 9 over to OS X, made it Intel-based hardware, made it Unix-based operating system, and in all ways, except for not having a free and open source repository built in, it was a modern system, much more modern than the proprietary Windows. Who wants to use proprietary anymore? When the computer operating system, when one of the first computer operating systems to have a series of very well considered and well designed principles built in foundationally came out, it spread like a virus, slowly but surely. From 1970 to 1990, Unix wormed its way into enough places that the sort of mainstream could respond by how much they hated it. People like Steve Jobs, they hated the DOS prompt of IBM compatibles bad enough. But now this thought that, quote, real computers use another terminal-based interface, that could not be allowed to become what faces computers. Even if it's going to run our computers underneath the picture, you still got to put candy wrapping on it for it to be usable by the masses. And that was the Steve Jobs thing. And, originally the Mac was proprietary and its windowing system was proprietary. Now the Mac is Unix, and they've even given back their contributions to Unix to the to the world in the form of Darwin Unix. It's Apple's own version of Unix. Not a lot of people use it. You wouldn't deliberately go and install Darwin Unix, for the very important reason that most of these Unixes don't have a main software repo. Now, I guess they do these days. FreeBSD in particular must. I'll have to research that, see what FreeBSD does about their, apt install or their yum install. But one of the things that had made Microsoft choose Linux over Unix is looking at the debacle of, Apple choosing Unix but not having a free and open source repository that they themselves offer. Now, yes, there is Homebrew. I am the first to admit that Homebrew steps in and fills this need. It scratches that itch for the Mac community. But first off, Homebrew, it's not officially Apple supported. It's community supported, which, while rah, yay, is not the same as the Debian software repository. So a branch of Linux that was mostly about dependency resolution. Debian is the branch of Linux. Debian is the branch of Linux from which Ubuntu was derived. But the Debian branch of Linux was born on the concept of resolving dependencies and making software easy to install. Multiple software packages on the same machine that might have conflicts, still easy to install, because the Debian package manager system focused on conflict resolution, on dependency resolution. And this was different than the Red Hat package manager system that came before it, one of the other lineages of Linux, right? Two main splits. One big main split now. There's been others, but the split that counts now in the Linux world is Red Hat from Debian. Debian led to Ubuntu. Ubuntu is what Microsoft chose. So Microsoft chose the Linux that makes software easy to install. That's what they get from Debian. But what they get from Ubuntu, which derives from Debian, is high level of hardware and driver support. Because Ubuntu is made by a for-profit company called Canonical. So In the Red Hat world, if you wanted support for your Linux installations, you could use versions of Linux that are for-profit, commercially supported. CentOS, I believe, is in that lineage. And those use the Red Hat package management system, which now has, I believe, improved to the point where it does all the same things as the Debian package manager. So, you know, time moves on. Such systems have jealousy of each other, and they put in what each one lacks, and they equalize. So it's all the same, whether you yum install on a Red Hat descendant or you apt install on a Debian descendant. It's all really the same. But the command to do the install is different, and that's where a new movement is coming into the picture. Boy, where should this video go? Because there's so many things I could cover. The main thing I want to cover in this video is that Nix one, and that knowing how to run software under Nix through the command line interface, the Unix terminal, the bash terminal, is like reading and writing in arithmetic. It's one of the 3 R's plus history. Reading, writing, arithmetic. Arithmetic is an honorary R, just like Perl is an honorary, not Perl, but like Ruby is an honorary P language of the LAMP stack. They don't even talk about that anymore. The LAMP stack is so over because no one uses Apache anymore. Nginx has completely taken over for it. And nobody uses MySQL anymore because Oracle bought it. It went the way of Berkeley DB. Y'all remember Berkeley DB? No, of course you don't, because the NoSQL movement was killed in the free and open source world because ye old NoSQL database from like the 80s was bought by Oracle. I don't even think it was called free and open source software. It was just something that was developed that evolved a built-in database from Unix, actually DBM. It was a database management system based on key-value pairs that shipped as one of the Unix commands. It was in the Unix command set, so you had key-value database in there. And then somewhere along the line, it's called Berkeley DB, so I would assume someone from Berkeley said, you know what, this thing can scale. We can make this support, you know, millions of records. And they did that some ridiculously long time ago, before MongoDB, before Redis, before CouchDB, and this whole new wave of things that was, you know, promoted as a revolution in databases. NoSQL. Now you can just use key value pairs instead of breaking everything down into rows and columns, which slows you down, right? It's slow. If you don't really need it in rows and columns, if the queries you're going to execute don't have to be against, you know, columnar, you know, row and column data, then you might as well capture it fast with key value pairs, where the key is usually the API call that fetched the data. It could be a URL, for example, because keys just have to be something unique. It's a key value pair. So the key is some unique value. And the value is anything. And to make it be able to be anything, oftentimes what's called a blob is used, a binary large object. Binary large object. So you plug in that key, that URL or whatever, and what comes out can be anything from an image to a text record to an XML text record to an executable file, a .exe could come out of it. Anything, you know, that's savable in binary, which is everything. Now, to get plain text and other things into binary, it is converted to binary. So there's an encoding issue when you take it out from binary if it has inside instructions for what its encoding is that can often be used to decode it correctly. And usually just whatever software you're using to pull it back out knew what it was going in, so you unserialize it, you decode it when you pull it out. So this is a convenient way. Say if an API that you're hitting against returns JSON, you just store the very large JSON object as the value of your key value pair. The URL becomes the key, the JSON response becomes the value. Now, you can even go one step further, and instead of just storing the text of the JSON as the value, you can also store the entire response object. So you can see all kinds of web server based things about the response, like the response headers, mostly the response headers. You can inspect things like status code, whether it was a success 200 or a 403 forbidden. It all gets encoded into the metadata, stuff that usually is outside and around and wrapping the JSON of the response. And it's normally lost because most developers don't even know to look there. But when you've made the request against some system and you're holding it because you have just received the response to that request, that whole response object can become your value in a key value pair. And then you can always, extract and transform it from key value pair into a more structured row and column type thing. So this key value methodology has been in Unix for a very, very long time, but it's been hidden and suppressed. The DBM program on its own, which I think is still in there, very few people choose to use for whatever reason. And everyone jumps onto the SQLite bandwagon. For very little cost, you get a very capable little SQL server that's been compiled. This is one of the great benefactors of C programming, right? So I keep hitting on this point because there's this elusive, almost mysterious, nuanced point about modern tech. Most people feel it, they can feel it, that the C programming language is special. That everything ultimately has been programmed in the C programming language. Hasn't it? Isn't that what tech is? Now, the broader perspective people lack is that what C brought to the picture is it was written for the operating system, Unix in particular, more so than it was written for the underlying hardware. Many languages that came before C were written for the underlying hardware. When you ran the Fortran programming language on one of these IBM mainframes, that version of Fortran was written for that hardware. Now, there are often advantages to this. You get higher performance because it's written for the hardware. It's hitting the metal, such as it were. But you lose portability. Now, maybe not, so long as that Fortran was written for a lot of different hardware. So Fortran is written for this hardware, Fortran is written for that hardware, and then any program that you write in Fortran can run on any hardware that has had the Fortran programming language ported to it. This is the way things were before C, is what I'm saying. Once C came onto the picture and demonstrated the key bootstrapping trick. What is the bootstrapping trick? Well, it's a chicken and egg problem. You have a piece of hardware. You want an operating system on it. The operating system is written in C, and so need only be compiled for that hardware. Now, the problem is the compiler has not been written for that hardware yet, and it's hard to write a compiler for that hardware on that hardware because you don't have an operating system yet, and you don't have the C programming language and editing environment for it on there yet. You see? Chicken and egg. So to bootstrap this process, you cross-compile. So for it to be kicked off in the first place, a C compiler need only be written for some piece of hardware directly. Probably it was PDP-11s back in the day. Once that has occurred, now you can create a cross-compiler. You can compile a C compiler on hardware A that will execute on hardware B because you teach hardware A about hardware B. You get it? So cross-compiling solves the chicken and egg problem, and you've got now a compiler for a new piece of hardware. You've got the compiler for the new piece of hardware. You load up the operating system code for Unix and you compile that. Now suddenly you have Unix, you have an operating system on this new piece of hardware. What a miraculous trick is that? This is what made Unix and C, because what's the language the operating system is written in? What is the language you're loading it up to compile on this hardware that now freshly has this new compiler on it? Well, the answer is C. So that trick is so powerful that now everything modern is at some point written in C. I would venture to guess even these things that were traditionally written for particular hardware are now written in C so that they can cross-compile. And one of the ultimate ironies, I'm sure Lisp, new modern versions of Common Lisp, I'm going to guess are written in C. I don't know for sure, but I would check it out. And same would go for Fortran, any modern implementation of Fortran. It would be insane to do it in anything other than C, because C is a low enough level. It's not a low-level language. It has the reputation for low-level now because on the spectrum, it's low compared to your Pythons and your JavaScripts of today. However, on the real full spectrum of high level to low level, C is actually pretty high level. And that's because it goes through some abstractions, which are virtual machines, whether we really call it that or not. You know, we don't call it a virtual machine with C because there's no P code in the picture. There's no intermediary code that can be moved between hardwares without a recompile. You need to recompile, but the fact that you can recompile code written in C for different hardware platforms may as well be a virtual machine trick. It's using the same tricks. It's machine translation layers to thunking it down. You know how I talk about how digital is one of the original lies in thunking down of the resolution of reality, turning infinite variety, infinite analog reality through sampling into ones and zeros. So the universe isn't really ones and zeros, but turning it into that for easier calculations is a big trick that binary does, digital electronics. So this is very similar to the virtual machine-ish stuff built into the C programming language. It's thunking all technology down to this common interoperable machine language. How's it so high performance then? Well, because the compilers are really well optimized over the years. It's solving this one problem over and over and better. So the optimizers and tweakers really know where to focus to get a good compile. And what is that compile? It's an executable file for your particular hardware. That's why the .exes for Windows don't run under Linux. Linux binaries are called ELF files as opposed to exes, and they rarely have extensions. If you look in the bin directory, you don't see .elf. It's just an executable. It's a file name. The operating system just knows it's an executable because has the execution bit set on the file attribute. So anyway, where am I going with all this? Well, Nix won. Because Unix and Linux won, the world is significantly changed. We can include technology. We can include operating systems in basic education, right? It's like teaching English. You got to choose a language. You teach people their native spoken language, which in the United States is English, so you have English in the public schools. That same consolidation has occurred on operating systems. That changes things. Things are now at a new state in human evolution. If you consider literacy part of human evolution, it used to be a privilege of the haves versus the have-nots. Those who are literate keep their wealth and power. And, Benjamin Franklin makes libraries a public resource, so the public has access to books. Of course, the Gutenberg press before that makes books accessible to, people of less moneyed peoples, and, so on, to allow the average person, the 80% of the people on the average distribution curve, the most people can now be literate. And this wonderful gift of transgenerational transmission of information, unlocking information that gets sent down in a meaningful way. I'm not talking about watching YouTube videos, and I'm not talking about, watching a movie or a documentary. That kind of experience is not the deep immersion of reading. Reading for pleasure sets apart people who had to read in school and don't read from the time they get out of college or whatever. People who read regularly for pleasure exercise those parts of the brain that turn them into powerful, genuine people. People who are powerful and able to do those things that they consider themselves about. That's literacy. Unix/Linux, collectively known as Nix, is now like that. It's literacy. It's got to be taught that way. It's got to be one of the courses. Early enough along. Here's how machines work. Here's how reading works and writing works. Here's how math works. Numbers. That's how numbers work. This is how our history works. This is how we've become who we are. That's problematic because the winner writes histories and everything's biased. Game theory should probably be in this category. Here's how games settle into fairness, or else no one would want to play. So that's kind of like social studies. Game theories is kind of like the social studies part of history. Understanding zero-sum games, understanding ultimatum games. Being able to express such things in code. Making code the encoding and decoding of information that can automate machines no different than the encoding of and decoding of information that can communicate to other humans. One of them we call literacy, reading and writing, and the other we call coding and programming. That's probably not good labels for that stuff. Probably better labels would be, I don't know, I put myself on the spot there, didn't I? It should all just be literacy. There's literacy to humans, and then there's literacy to machines. Machine literacy. Machine literacy. With a general understanding of the history, why C is a special programming language. And not all C's are equal. C is something that gets decorated and snazzed up in different ways. C++ for object-oriented C on Windows-like machines, and Objective-C for yet another take on object-oriented C for Macs. But because you're only learning to program for Macs with Objective-C, it goes out of style. It's hard, you got to learn these messages that came from Smalltalk, things sending messages back to each other. It's a different model. And Python has become so popular, and in Google copying many things from Python when they made the Go programming language for system development. When Apple chose to make a new programming language for app development. So, Google is the master of the back-end systems because, most of what makes Google great is what runs on their servers. And the apps are of not much real consequence, right? They're kind of simple. But Apple, on the other hand, is all about enabling people to make apps so that they can put them in the App Store and make money, right? So Apple has a lot of incentive to make the front-end user interface stuff a lot better. So they created Swing, which also was highly Python inspired. So you've got one system language on the Google side, the Golang, which is inspired by Python. And then you've got another language on the consumer Apple app development side, Swing, which is also inspired by Python. Boy, someone's following me closely on this road. Good, I'm glad they're turning. It's like a 25-mile-per-hour road, and I'm already going much faster than that, and they're right on my butt. So I'm going to come to a full stop at the stop sign just to mess with them. I shouldn't do that, but... So everything's inspired by Python these days. Python is the thing that got it right. And you know what? I talk so much about Nix having one, Linux and Unix having one. That's the spoke at the center of whatever other language is your poison, whatever is your preference. If you're using Node.js and JavaScript, that's fine. But ultimately, it's run from and funnels communication through Unix or Linux, using all these wonderful computer science principles about what an operating system should be. It should have a similar set of commands that, follow these similar principles of, few commands. Each thing has a lot of options, and then they can pipe, each other's output into the input of the next, so you can chain it up in pipelines. And everything's a read-write file. So you put a few of these principles together, and you've got a modern operating system. Since 1970, you've had this. And, from 1970, 80, 90, by 1990, they realized that this, well-designed computer science-y operating system is spreading like a virus, and the Unix Haters Handbook comes out. It takes 20 years. That's 1990. In another approximately 20 years, maybe just a little bit less, the writing's on the wall even more. So it goes in 20-year cycles. We're talking from 1970 to 1990, Unix Haters Handbook. From 1990s to 2007, Apple's like, oh, okay, we give our proprietary operating system on Macs is now going to be Unix instead of our own stuff. And another 20 years approximately, no, not really, it's like 10 years, 2007, 2017, 18, 19, well, we're well on our way to another 20 years. And Windows comes around by allowing the Linux operating system to run side by side with Windows, equal and next to it. And so isn't that amazing? Unix, after 50 years, is only really just now settling in as the operating system that won. It's Unix that won, but it's Linux that became the messenger. It's Linux that became the embodiment of Unix. the Unix way is the Linux way. The Linux way is the Unix way. So these NIX operating systems won. And and they're at the center of this hub of interoperable communication. They're all about IPC, inter-process communication, or at least, the ability to pass information between applications. Almost the same thing. They got slightly different connotation, but that's the basic idea, and that the APIs never change. 50 years and it's mainstreaming. The APIs are very consistent. And then the final pieces of the API that resisted falling into place are now finally falling into place under systemd that I talk about a lot. And this all now exists under this very convenient container system, which is much better than virtual machines that came before it for countless reasons. I'll probably be talking about this a lot in videos to come, but containers rock. And I'm just getting a feel for them. I'm really just getting the reins of the containers now, and I super duper look forward to sharing that with you, because I'm having my key insights. It's stuff that's hard to wrap my head around sometimes. These key insights are tricky ones. I just realized that SU stands for switch user. It's not super user. I combined the SU concept with the sudo, because we're all doing sudo in some command in order to sudo as the super user. So SU stands for super user, and sudo, sudo, it stands for super user in that command. But SU on its own stands for switch user. I got hung up on that. Wow, I needed to clarify that in my mind, because some of these LXC commands that I really need to understand use SU to do a neat little trick of immediately switching user when you log in as root. So root has the ability to switch user even without a password. Very slick, very important. It must be understood to really grab the reins of these containers. So that's a good place to end. I'll pick up there soon and share with you these LXD discoveries.